All right, folks, I want to take a quick look at how we can use some other analog input devices and sensors with our Arduinos and circuit playgrounds. So I've got my multimeter out and I've got a breadboard, and I'll just look at a couple of things on here first. I've got a potentiometer, and the two outside legs on that, I've got one going to power and one going to ground, and then I've got my power and grounds linked from side to side of the board here. I'll talk about that in a minute. And so what is a potentiometer? A potentiometer is commonly known as a knob. So you'll see these on all kinds of audio interfaces, on stoves, on car dashboards, like anything where there's a knob that you twist, it's usually connected to a potentiometer if it's an electronic device. And so behind that tactile knob that you interact with, there's a variety of form factors that these things can come up in. So we looked at this one just now. It has a little post. You twist the post, and that's the twisting motion for this knob that's really designed well to go on a breadboard. Without the knob, that would look like, if I can get it in the camera here, this little guy. So it's got three legs, one in the middle, one on either side. And this one you would need a screwdriver to actuate. Here's a bigger one. It has a whole disc that rotates. And again, the three legs. You might have an even larger one that's like a metal post if that came with your kit. Now, usually they will say on them their resistance range. This is 4,700. This one, you can see that is 250,000. And this one is 10,000. And so these are basically very voltage dividers. They're resistor rings, and it's splitting between those rings. So if we measure like that middle one, all the way on one side it's going to be 0, and then all the way on the other side it will be the full 4K7. Let's take a look at this one so we can really test that out. I'm going to put my multimeter in ohms. And to assist me, since I don't have three hands, I'm going to use one of my alligator clips. I'm going to put this on that middle pin, and then I'm going to clip this to my probe. So I've got that connection made, and so now I just need to use this -1, and I'm going to hold that on my negative connection point. And we see I've got 5.24 thousand ohms. And as I adjust this potentiometer, I can go down to 4. I go all the way down to one side, all the way down to 7 ohms, right? Almost 0. And then let's crank this up all the way. And we go all the way to 9.27 thousand ohms. So that's pretty good for my 10K pot, and that's about what I would expect to get as a value range out of this. Okay, so let me put this away for a second. And let's look at how we can look at this in code. So I'm going to bring out my circuit playground, and I've got my clips. My power clip is on one of the 3.3 volt pads, and my black is on the ground pad. It's really important that I use the 3.3 volt because I'm going to be sending this voltage back into one of my analog pins to read the value of the potentiometer, and I don't want to put that V out on there. because the V out's going to give me 5 from USB, and that could damage my pin. So I want to make sure I'm using the 3.3 volt. I'm going to plug these in, positive and negative. There we go. And then I'm going to clip this onto A3 like that. And again, I'm trying to keep my wires different colored. I've got the red wire for positive, the black wire for ground, and this brown wire is my signal. So with that set up, I can connect my power. All right. And let me see if I can twist this around so that's in the microscope. Great, so we can see the potentiometer now. Okay. And I'm going to go to my Arduino code, which is really simple for this. I've just got a serial.begin for the serial port, and then I'm going to say serial.println analog read aid3 in my loop. I'm not using any of the Circuit Playground Express library stuff, so I don't need that. And the analog pins are inputs. You can't, they're not outputs. You can't output analog. If you're doing an analog write, that's a PWM thing you do on a digital pin we'll look at later. So the analogs are always going to be read, so I don't need to set them in my pin mode up here is what I'm getting at. So let's look. I've already got this uploaded, and so my knob is all the way over. That's how I left it, and we're getting a full 1023-ish. And as I dial this down, I can bring that all the way down to 0. So this is really neat. So that 0 to 1023 is because I've got the 10-bit analog channel here, and that's indicative of the voltage that it's reading. Now, that 0 to 1023 by itself doesn't tell me the voltage or the resistance of my potentiometer or anything like that, but if I know the resistance of the potentiometer, I could use math to figure out the voltage that I'm seeing, right, using Ohm's law, if I so desired to figure out what that actual voltage was. Usually, just the 0 to 1023 signal is enough for what I'm going to do with my programming. So that's looking at a potentiometer. Let's look at a couple of other sensors. And to do this, I'm going to unplug this and move some of this stuff out of the way. Two other sensors I want to show you, and there's a lot that work this way. They're variable resistor sensors. One of them is this little photo cell. It's a light sensing cell, very similar to the one that's built into the Circuit Playground Express. And here is a force-sensitive resistor. This is a pressure pad that you can squish, and it will give you varying resistance based on how much you squish it. This one will give you varying resistance based on how much light it detects. This one is like what's in a drum pad interface, if you've ever played with one of those. So let me show you what each of these does on the multimeter. Again, we'll put that into ohms. And I'm going to hold this light sensor with one of my probes on each leg. And we can see it's at like 4.5 K. If I move this towards the light, 3, 2, the resistance goes down. If I try to cover it up, it goes way up. So now we're at like 44K, 45K. and back down to 4. So that's how these work. More light is less resistance. And with our pressure pad, this is going to be a little tricky. I'm going to hold the probes on either side of my, like there, okay. And we're getting some resistance. And as I squish this, it goes down. Okay, it's a little hard to see the multimeter here, so let's look at this in code. So unlike the potentiometer that has 3 legs, these only have 2, okay? So we kind of need to if we want to measure the voltage coming off of them, we need to set up our own voltage divider so that we can see that voltage change or the resistance change from the variable resistor. So what I've got down here is a 10k ohm. It's a brown, black, orange resistor going into my positive line, and then one of my rows, and then I've got right next to it a just wire connecting the ground to there. And I'm going to put my, I'll start with the light one. I'm going to put this in, if you can see that. So just going from one row to the next, the legs of that sensor. Okay. And my connection point, my sensor that I'm gonna read the pin on, I'm gonna connect this right here between the resistor and my sensor. So if I was to draw this circuit out, here's our 5 volts. That's going into this 10k ohm resistor. There's a connection point here where this is going to my pin, and then this is continuing to this photoresistor, variable resistor, and then that's going to ground. Okay? So that's what this circuit looks like. Compared to our potentiometer over there, which was 5 volt. Ground. And this potentiometer has like an arrow there, and that arrow is what's going to our pin, or was going to our pin. All right. So we can go ahead and plug this in now and see what kind of data we get. Here's our serial monitor. And so we're getting the ambient light environment here is like 390-ish. As I move shadow of my hand over it, it goes up. To about 700, 790, 800. I moved away back down to 3. If I try to really hold over it, I can go up to 900 something. So that's the photo resistor. Let's look at the force pad too. So I'm going to disconnect my power, take this off. The circuit is the same, right? Because this is also a variable resistor. I'm just going to slide that into those same 2 pins that the photoresistor was, I've got my 10K resistor there to help me with the voltage dividing. And so then I'll just be able to squeeze here, and I'll flip this around. These, because they're variable resistors, they don't have a polarity either, right? So whichever way you put them in doesn't really matter. So now I can squeeze that and we'll see the force change. Let me connect the power again. Here we go. And so you can see when I squeeze, my reading goes way down, and when I let go, it goes way up. So there's pretty neat. So you can get a bunch of different sensors like this. There's these FSRs come in all different shapes and sizes. You can get very long strip ones that will let you know like where the position linearly something is pressed versus how hard it's pressed, which is what these ones do. You can get flex sensors that are also long but bend, and so they can measure like the degree of bend or something, or how much something is bending. There's just all different kinds of sensors that you can use in this same kind of setup and way. So I encourage you to explore some of those other sensing options beyond what's built into the Circuit Playground Express.